Yeah, this is the VNC number I got. Thanks. Okay. Yeah, what is your doubt? Saroja, can you?
Sir, sir, in the layout, op-amp only shows the lab, not shown the diagrams. It means yes.
Okay, you're not able to see op-amp.
Yes, sir.
Okay, so op-amp new symbol. Okay, so when you are doing symbol, just take the instant. Don't do copy paste. Actually, you did the one mistake. You did copy paste.
Yes, sir.
In this or here? Op-amp new symbol. So close. This you can connect it to VDD VSS. Now you can take. You just select it. You will check and save. If not coming, it should be come. Otherwise, you can close and open it.
Okay, sir.
Okay, that's only your doubt or any other.
No, sir, that one only, sir. Thank you, sir.
And now you can select come under this match. Okay. If the schematic you just need to extract, click OK, extract, okay. If it is not coming, you can select all. I think you have done. Yeah, now it is coming open.
Yes, sir. Okay, sir.
Okay, that is
complete.
done. Yeah, that's done. And sharing with on. This one you know how to do. It will take on.
Yes, sir. Yes, sir. I know, sir. Thank you, sir.
Yeah. So any other having doubt?
Suresh, Pankaj here.
Yeah.
Can you please connect to the session 92? Hello.
Yeah, I'm just connecting your password. Yeah, Pankaj.
Is this metal 3 you see on the top right hand corner?
Yeah, this is not the correct thing. So how you cross check whether it is, if you, this is the metal 3, not the proper drawing. Here, just delete this.
No, I'm talking about metal 3, not metal 2.
Okay. So if you see the exact thing, see, this is your technique. This is not a metal 3 drawing. It will be come here, here. This on the exact metal 3. It will be like this. Okay.
Okay, okay. Can you drop a via metal 3 and metal 2 via over there?
Yeah, now it will be come.
It's not aligning with the. Okay, you're doing align. Okay, fine.
Yeah. Now it,
Okay. Okay, thank you very much. Basically, I was not using the right layer, right?
yeah, yeah,
Suresh?
exactly. Yeah, you are drawing this one. If you go to this is slot and this is your drawing. So this is not the correct thing.
Okay.
Always take from this one. Like wherever Bhiawa is there, you will see.
Okay.
Yeah, this one, this green metal 3 drawing.
Okay. Okay. Thank you.
Or if you stretch also, yeah, if you see upper, it is saying metal 3 drawing, M1 drawing. But if you select here metal 8 slot, this is residual DOM drawing. Everything it will tell here. What you are drawing is this one only. M3 residual DOM drawing. So this is the different layer.
Okay, got it.
Okay. Yeah. So any other having doubt?
Hello, sir. Pratik here.
Yeah, Pratik.
Yeah, 24 number GNC. I don't think doubt, just a small question. Yeah, here this all 6 pins are connected. This all 6 pins are connected, right? So instead of path, we can just rectangle and put it over.
You will face DRC.
Actually, I tried. But it is the right way or not?
It is not the right way because we will like take exactly. We can extend means this is 0.6 up to 0.6. It is fine.
Okay.
You can take up to 0.6. That is not a issue, and it will be good also. Suppose this is for current like EM issue. Suppose more current is going to be here. So 0.6 width will be sufficient to carry this. Okay, so I have taken 0.1, that is also sometimes not the correct one.
Hmm.
Width, if it is more also, so what will happen? Your more current will flow, so it will be tolerate that too much width,
Register is that current flowing fast.
and it will DRC also it will not ask.
Hmm.
Why I'm telling, if you take more width, so it will be metal to metal spacing error.
Hmm.
And here it is fine, already it is aligned. This is the correct way. For other also can take like this. Okay, this is here it is not possible. Wherever here, like this 4 line it is possible. And some people will face the main thing here, annual. Okay, annual if you see, this is I given rotated. So don't make all 3 annual closure. What I am trying to see, just I will undo it. If you maintain like, it will ask you 0.1, 0.2 error. It is not in 1.18. That's why I have rotated, so that your area also minimized. So for rotating, how you will do? Suppose anything you want to rotate, the letter 1. Let assume this register. I want to rotate it. So here this symbol, see this is 4 line is there. So this is like horizontally you will rotate. Okay. This horizontally 180 degree. Okay. If you want to click the 90 degree, this is, see, this is rotating 90 degree. Clockwise, anti-clockwise. This is in this direction, this is this direction. Anti-clockwise, clockwise. So this is the symbol. 1, 2, 3, 4. You can cross verify. Can I just undo it? Yeah. So any other having doubt? Okay. So today I will go for new topic. So before that, just clear. Anybody having doubt? If you stuck, then you cannot do other, next project also. LDO is a simple schematic only. Okay. So nobody having doubt? So next point is low dropout. What does, and its application also will see. But before that, low dropout. The output voltage will be low. So this dropout. Okay, I'll draw the schematic. Okay, so this is the PMOS register you can tell R1. And here the multiplier will be more. Why multiplier will be more? We'll talk later. Sometime you will get 100 also. For this also we will take 100 multiplier. This is the only challenging in the LDO layer. This thing will come to later, but for that will prove this. This is a low dropout. Okay, so it is completed. See, any voltage will be vary in the VDD. P out will be less affected. So how it will be affected? Let's come to. So if it is V reference, so it is like positive, negative, inverting, non-inverting. This is a non-inverting, inverting. So what is the voltage here? You know this is op-amp only. This is a op-amp. A virtual ground concept. This is also V reference. So this value also V reference. So if you calculate like voltage division rule, and op-amp will not carry any current, so current will not be divided here. So current will be go to directly straight. These 2 points you have to remember. So this is V reference. This is V out. This you can tell ground, zero potential. R1 and R2. This some book you will find R1 R2 different. Okay, so as for the schematic, I am just taking same as for the schematic of the okay, R2 is nearer to ground, correct. So V out R1 R2. So you will see. So what is the V out value will calculate. So before that, so like this is the V out means total voltage. So V reference equal to, you know, this potential. V reference equal to total voltage division formula. Total voltage into corresponding resistor R2 divided by total resistance R1 plus R2. So now what is V out? Equal to, this is just multiply here, V reference into R1 plus R2 divided by R1. So finally V out equal to V reference 1 plus R1 cancel means 1 R2 by R1. So if you say V out is independent of supply voltage. So any changes in V reference, V out will be changed. So as is independent of supply voltage, so that's why if you change 5 volt, 3.8 volt, generally this voltage is generally 3.3 volt, 3.3 to 3.6 voltage. But it is independent of supply voltage. That's why the drop across V out is very low. There will be drop. This is theoretically we are proving it, but practically there will be drop because it is current will be coming here like this. Drop will be there. So, but that drop will be very less. There is a point. You got the point, because the output voltage is independent of supply voltage. The main reason for that. Okay, next come to why it is multiplied. This device, actually this MOSFET is called power MOSFET. So power MOSFET will drive a huge amount of current. So its application generally power MOSFET always high amount of current. So in this VLSI, So milliampere, ampere current you will not find anywhere. Milliampere. Okay, so our technology will be like 2 milliampere will carry 1 micrometer width. This is just assumption we are doing. 90, 65 almost same only, 65, 45 also. So 2 milliampere will carry 1 micrometer width. And this is how the EM we are calculating. If you maintain from layout this, okay, so for this, how much current will be flow? Okay, just complete this writing. I will give you time. Because some people are not done. So just use the derivation. Okay, so now come to why this 100 multiplier. See, this is not a fix. This is the one design you're giving. Some tech company they will follow more than, but this multiplier will be definitely more will come. Like 100 is the one example. You will not get 2, 3, 10 multiplier. It will be above 50 only. Okay, so when the designer they design, this will be the current will be little bit more. So current will be, let us assume 20 milliampere. So if it is more current is flowing, so one device cannot tolerate. It is not sufficient to tolerate. So one device will carry how much? 20 divided by 100. So 0.2 milliampere current. Okay, so you have to design also width. So as I told you, 2 milliampere will carry 1 micrometer width. So 0.2 milliampere will carry 0.1 micrometer width. So if it is 0.1 micrometer width you are designing, that is sufficient to. But for worst case, like you will plan for 0.2, little bit extra width you will take, so that you will not face any EM and IR violation. Understand? Or anybody having? Okay. Sometime also, suppose this width is not sufficient, you are not able to do for DRC clean, so that time metal stack also you can use. Okay, so anyhow this layout I will do also. So before I'll do schematic first. Yeah, anybody can tell the whom already I did Pratik. So this time I will do somebody else. Who is using mobile now? Okay, mobile that. Who? Okay, otherwise I'll do mine. You will be practice. The new schematic is LDO. So then you can take PMOS. And this width also a little bit more generally when the designer design. So before that you are taking only, so you can take 1080. 1.0 it will come micrometer. Why? Because the width will be little bit more. So that when you do horizontal routing, so 50 multiplier. Okay, if you see the layout, you will see and you will get clarity. Say 50 ohm, so you can change by length only you can change. Now we are considering about EM also op-amp case, but op-amp if you see this current is going, but this current is not dividing to op-amp. Gate will not carry any current, and here also not current. So op-amp current will be very less. So that's why we are not bothering about EM. Sumit, you understand? Yeah. So here current is very less in case of op-amp because gate will not carry any current. That is the main point. And this current also here resistor. The current will be here. The op-amp input also will not carry any current. So this 20 milliampere op-amp will be carried very less. Even it is microampere like 650 microampere or nearer to 1 milliampere. That current is very less compared to this current. Okay, this is you in the interview they might ask. In this way you can calculate. I can give you any milliampere, you can design the volt. Okay, suppose they will ask you design for 10 mill. Okay, so 5 milliampere. So what is the width? Just multiply it. Just divided by 2. 2.5 milliampere microampere. Okay, if milliampere microampere, if it is microampere, just divided by 2. 0.25, then as for milli to micro you can convert anything. In that way you can do, or you can calculate like how you are calculating. That also you can calculate. Like 1 milliampere kali 1 by 2 microampere. 5 milliampere kali 1 by 2 into 5, 2.5 mic. Okay. As per the how you are calculating, 1 milliampere will be carry 1 by 2 microampere.
This current density will be defined in the process manual, right, Suresh?
Yeah. PDK it will be. Means it is PDK. You can the part of that DRM file. You can tell design manual.
Okay, thank you.
So this is just a op-amp, sorry, LDO. So I will do this one only. So this is op-amp already you done. Register to connection you can do, but challenging is this routing. So this routing I'll do now. So current is 20 milliampere. So first you plan this current, how it is going. So 20 milliampere means how much wood you require. So 20 milliampere will carry 20 micrometer wood. So your total wood should be 20 micrometer wood. But this wood, how it will, you cannot take directly 20 micrometer wood. Okay, let's see. How much area you will take 20 micrometer wood? Okay, first a device I will take, then you can do segment also your wish. But anyhow, register. I'm planning like this. So how many row? Each register means each device 10 10. So 5 into 10. Okay, the current is 20 micrometer. So 4 micrometer width is sufficient. See, this is, if you see 180, so it will be or you can take A square sub means 5:10. Okay, so I'll take 5:10 only. Let's see. And you can do sharing also. So this is I'm just doing sharing. Poly to poly 0.32. All get together. It is just repeating, you will not forget. Again select Q, come on. It is not coming. Something else is selecting. Okay, let's see. Sorry?
Marker.
Yeah, marker meant. Yeah, correct.
Hello, sir. What is the value of resistance?
50 ohm on. I can see here 50 ohm. The devices is 1.08 or 1080 micron. This with a little bit more.
Okay, sir.
Multiplier 50 I have taken. Something wrong I did. 100. Sorry. Yeah, it should be 100. See, you can do little bit fast also by doing. This is called no need to do also. But Excel connectivity will not find. This is the disadvantage. Eight into 10, 80 still 2 there. Okay, so with total width I told you. So how will maintain? You will see now. Total width is 20 milliampere, means it will be sustained to 20 micrometer. You can place guard ring also or clean the DMOS and tap. Okay, this P implant to V implant you will get error, so you can draw it. be implemented continuously. See, it depends upon my floor plan I arrange. So for your floor plan, you can extend also. Means it should be looks like square shape. That will be good. Okay. So next point is current routing. So this routing is important. So first to complete only this, it will reflect to other. So for that, I will do synchronous copy or cloning. So what is the advantage of cloning? One day I also told, but I will implement here also. So what is the advantage? Okay, let's see. So this is connected to VSS. Sorry, VDD. So I just do I'll not connect M1 like this. So how will connect? You will see just a different type of layout. So why I am telling, I'll tell you. So 0.5 to 0.5 can take 10 micrometer width. 20 milliamp will carry 10 micrometer width. So 10 micrometer will divide it to so you have how many tracks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 tracks current will be divided 1 ampere each. 1 micrometer each. But I am taking maximum how it is possible. 0.5 also not suitable. So what I will do, I will take 0.4. I think you will not face errors. Now I'll do metal stack also. Okay. So what is metal stack? Why I am doing? So 0.4, 0.4. So current will be divided. So but this width, if you see, this is 0.4. So 0.4 into 10 times, you'll get 4 micrometer. But our width I need 10 micrometer. Understand? Because 10 track will be there. The 0.4 into 10, 4 micrometer. So which is not sufficient. Then to avoid this, we are using a metal track. So I'll just show everybody can do just a why I am doing synchronous copy also I'll tell you. Just do this one routing. All this routing will be copy paste. And this will be automatically it will be. So okay, what is synchronous copy? And metal stack. So first I complete metal stack, then I'll tell you. You don't need to do all thing every time. First you understand this is 4 micrometer how because this is 10 track. The 0.4 you are taking. So I'll take another track. Another track means M3. This is the metal stack. Over M2 you have to place M3. This is M3. Exactly same width. M3 track. This is so now total width how much? 0.8. M2 and F3 which combined 0.8. But still also 18.8 into 10 times 8 micrometer. That is also not sufficient. Then you have to use M4 track. This is the when current will be more that this thing. This is called metal stacking. Okay. Give it metal 4. So now it is sufficient to take 12 micrometer up to width. And you can use auto here. Now it all will be sorted also. Okay, now if I use auto, see all VI is coming like this. This is not the correct way. Okay. But first you understand this is the metal stack. So I'll turn on M1. M2. So M1, M2 you can sort. This is like alternative. One will be source, one will be drain. Now if you see the connectivity, let's see. See, one alternative it is connecting. Okay. Then you can turn M2, just leave it M2. See how I'm just, otherwise it will be short both. Now you can highlight again. If you highlight, gray mark, okay, we'll check one by one. M1, VI1, M2, if it is not there, you can use auto. Now it is everywhere there. This is how, okay, what is, this is the first thing, but I have taken a little bit extra. It will be later you understand. Okay, so I'll make this synchronous copy. First you select this, all the routing, create the group name you can take in. This is the group. Okay, what is synchronous copy? I will just copy this. F3, create synchronous copy. You have to click man, but you should have Excel connectivity. In L, this option synchronous copy will not come. Okay, so what is the advantage actually I want to show you? Suppose by mistake this is you are getting some DRC error. I need to delete. See, update all from. Okay, I delete something. So this VR deleted. So in the here also it will be deleted. Understand? If I deleted anything, see in the below also it will be deleted. So this is the advantage of synchronous copy. Okay, for me all connection is done. I'm just deleting this one. So copy, you have to align this one. M2 will be aligned to up one. Copy F3 synchronous copy. Or you can copy, suppose you want to copy 9 times. Column 9. Just I place here, see 9 times it will be come also. Okay, 9 times it will be come. Exactly same point. Now, why I little bit extended? Why? Because, or it is your choice. I will not extend also, that is fine. But if you now connectivity, okay, so I will draw, this is 10 micrometer. This horizontally you make, but vertically also you have to maintain 10 micrometer. How? You have to draw F3. M1 via M2. Okay, connectivity I'm just checking. This is correct. Below also correct. M1 via VA2. Okay, VA2 I didn't place here. Okay, suppose you want to place VA2. Go to X. See, update all clone from the family. Okay, it will be update everywhere. I'll turn on M2 and VA2 M3. Okay, here I did some mistake. I'll just place auto VI I can place. Oh, auto VI. See, it below also it will be reflect. That is the advantage of cloning. So this is, you can learn many things from this layout only. Here VI is not there. Okay, and now back. Okay, so if you want to make vertically also, but if you use M2, all two will be short. So you have to use M5 here. So this is M5. M5 width you can take. Little more only it will require. So wherever the maximum possible, so 5 around I can take. Even 5 it is not. So actually our width is 10. So here also metal stack we will take. This is the very challenging situation. If it repeatedly coming, you can change to one metal tube. Okay, so M4, M5. I use up to M3, M4. Okay, this is your M4.
The width of M5 is?
So I have taken 5 because why? We need 10 micrometer design. So still also it is M5 I have taken, but still another 5 this side I have taken. So that you can tell. Okay, what is M5? Okay, by mistake I have taken M6. This is your M5. Okay, M6 also I am taking because this is the M6 also, that much width is not required. So 5, if you add, it is also 10 micrometer. In your 5 micro, it is lots of sufficient. Because this EM it will be different, you will be carrying more current also. Apply. So one will be VDD, one will be VSS. So you will use how will be connected. That is also alternative. This is VDD, this is VSS. Like this you will connect. Try to make it center nearby. See, alternatively I connected. This will not come under synchronous copy. Synchronous copy disadvantage also there. You can this one you can do auto via alternatively. Okay. Now cross check whether all gate are connected or not. So I'll go to control 1. Means whether whatever I did it is correct or not. M1 connectivity. Okay, these are highlighted. See, if I am highlighting, all are highlighting this side. If I highlight this one, it will be highlight this side. Now for gate you can take M1. M1 you can sort. These all gate are sorted. And this gate will not carry any current. So this width will be less also fine. So this is for exactly you are maintaining. This is the challenge, this one. And gate last what we'll do, all gate also you need to sort. So you can use M2. Okay, this is the M1 you can sort. This is how we can do. Or okay, this is in the synchronous copy also you can take. Put X. If you draw one M1 layer, it will be reflected everywhere. F3 can change 0.14. See, this much learning is, this layout is very helpful for synchronous copy layout. Okay, I'll go to back. You can see all M1 is sorted now. This is a synchronous copy. You are not doing this layout routing. Automatically one, if you do correct, everything it will be reflected. Okay, for all M1 you need to sort. So what we will do, you will draw a M2. One M2 is sufficient. But I don't know if you DSC asking means you have to 3.14. Outside you can draw M3. Okay. You can sort this all gate. So this side gate connection, this is like source drain. Understand or anybody?
Yeah, hello sir.
Yeah,
Instead of putting gate contact, we can directly use the poly to sort the gate.
poly to I didn't get poly.
For the gate contact, we put the gate, right? Gate contact.
Yeah.
Okay, instead of that, we can use direct poly to poly.
And yeah, that is the last option because poly having high resistance.
Okay.
If you compare poly and M1, so poly is a high resistive. If resistance more, it will create more drop. Or more resistant mean timing. You suppose this gate will be turned on some different time. Due to resistance drop, it will be take delay. So generally not preferable to draw poly routing. That is called poly routing only. It will add the extra resistance. Okay. So this is the way to, if anybody having doubt, even DRC if you face, let me know. Might be M2 DRC, then we will do some different thing. I think it will not be space. What is the minimum spacing asking? M1, M2 to M2? Might ask, I think other DRC will not be there. So 0.14. Okay, it is inside. Here it is no error. Okay, inside op-amp it is showing. In op-amp DDRC I didn't clean. It is asking. I think you will not get any error. Okay, the challenging issue you understand. And here anybody having issue. So what I did, this two line is not started. This is like one will be source, one will be drain. And this is the new type of DHC that question. New type of routing because of the current. Yeah, M2 to M2 spacing there. So 0.14. Yeah, if it is there, no need to worry. This M2 width he can reduce like 0.4 because I have taken 0.1. If you combine, this is 0.4, 0.4. Okay, so what we will do? I will clean this also. You can make to 0.25. Now it is fine. Here also it will be changed automatically. So why 0.25 if you reduce also, because that's why I have taken little bit extra. Total width if you measure, so 0.4 into 3 times. 3 times means M2, M3, M4. So all having 0.12. So I just reduce a 0.25. Even if you reduces one width, it is not affecting. Okay. This is how you will plan. This is like a this is like a now you are experienced engineer. You can tackle any 0.214 is not there. And why we are connecting M5? So all M1 will be sorted here. Okay, so somebody asking gathering. If you don't place gathering, you will face the latch-up error. Okay, one side if you place, this is not a matching device. You no need to place like all side, but it is better to cover because this is a power MOSFET thing also. Okay, I'll come back. Some people will be M1 also. Okay, this M1. Okay, that is also will be easier. All gate connection, you can use M1 you are telling. Okay, so for that case, what we will do? Okay, we'll see latch-up error we are facing or not. If not facing, you can do. Okay, so what is the latch-up error? I deleted the second because it is in malin. I deleted this garden. This is you can do, but if you place only one guarding, you will see DHC error, latch-up error. The latch-up error is there. If you understand this latch-up error, so what is asking? It will see one N tap for this NMOS for P tap. Every 25 micrometer, one two taps will be there. So to clean this, what we will do? You have to put another cap. Means 25 here. This tap to 25 micrometer. This is a total how much distance? Okay, let's see. We'll run it now. Still it is there. And did I place N tap or P tap? That is also N tap it should be. Yeah, this is the wrong. Guarding always in the matching device. And any of this is not a compulsory to place guarding. Everywhere also area wastage. I think you can use this technique also. Okay, you can align this annual to annual. Yeah, it is going to clean. No need to worry. I think you can do easily get connection. So then M2 is not required. This M2 not required. You can use M1 directly for sorting. Like this also you can use. Okay, so anybody having issue? Just try to complete this LDO. If anybody face issue, you can ping. You got the point? Why I am doing? Because of the current use. And synchronous copy. If anybody is facing, see, always do in Excel connective. In L, if I do L, the synchronous copy option will not come. Okay, so what will be if I copy anything, then F3 if you press, the synchronous copy option will not come. This is you have to remember. A normal copy, synchronous copy, I told. So this is the many people will synchronous copy first time you are doing, but this will very helpful. Your time saving. like only one time. I'm not seeing this layout routing. Only one routing you'll do is you just reflect. And even it is something wrong also, if you edit anything, it will reflect to other layout. That's the advantage. Normal copy you can do, but it will not reflect. At the time you will do again draw. Understand? Synchronous copy is a very helpful. Or this is called also cloning. Other name also cloning. And here also another type of clone, generate clones also there. So that also I'll teach you later. But for time being, you understand this. Okay, so that's all today. Yeah, so thank you all of you. Just try this layout. If anybody issue, you can ping me. And those who new people join, will start new batch. So no need to worry. This is for experience. We are joining this group. I think maybe 2-3 people are there. Okay. Thank you all of you.